Hello. So this is a little platformer game that I've been working on. And it's written in Rust with the Macroquad framework. And right now it's just a test. I've been working on it for a few days. I drew the sprites more than a few days ago, but I've only just started programming a few days ago, and I'm making some good progress. So I thought might as well make a little video just to put out there on the web, because you never know. And it's good to document these things, because maybe in a few years I'll look back and I'll think, that's cool, or maybe I'll think, God, what crap coding. Anyway, this is what I've got so far. So there's a player. This player here is a little fox that I drew, and you can see all of the sprites for him. These are just tests. This whole image is just a test. The final spreadsheet is probably going to be much nicer, and the skidding will be separate. The particles will fly up on their own. Here are some test things I drew, so you can see like a cool, wacky level, and you can see all the Mario sprites, because I've taken big inspiration from Super Mario World about how it does its sprites. I thought maybe he could hold a gun, maybe he could run with a gun, maybe he could have moon shoes and roller skates and big boots for stomping things and a helmet for smashing things. So I think that would be very cool, and some platforms and some bricks. All very nice. This is just some test sprite work, all in one big A sprite thing. So yeah, I loaded all these sprites in. Now I've got this player, so he can walk around just normally, or if I hold down the run key, run back and forth, which is very nice. And you build up speed when you run. So you start off slow, and eventually you reach a maximum speed. So I'll show you. When you stick your arms out, you reach a maximum speed. This level isn't the best for showing that off, but you can see you reach maximum speed. And you can skid, so when you skid it's nice and snappy. That was annoying to do, so it's nice and snappy when you've got high speed, but it's not as snappy when you've got low speed, which is good because it shows off the skid animation. You can run around, you can jump as well. Now jumping isn't finished yet, and neither is the physics. The physics is very dodgy right at the moment. You can see if I, for example, fall off this ledge. Actually no, maybe you could, if I fall off this ledge. Oh, okay, well there was a glitch, but it's not there anymore. So yeah, the jumping physics isn't as done now. I want to make it so the faster you go, the higher you jump, just like in Super Mario World and many other platformers. But that's not implemented yet. So you break tiles and stuff. So, how this is made. It starts off with just some stuff. Now, some of this code isn't very nice. I'm going to put all this in a lovely, beautiful thing that does all this for me. But for now, this is just testing built upon testing. This is a few nights of work of putting stuff together, and I've been slowly building up the main elements. So to start off with, there's something called a stage. And what that is just, it holds a bunch of tiles, which are represented as unsigned 8-bit integers, and a width for the stage. Okay, so I make a map here, and this map is 32 long, so I put the width of it as 32, and I just put all the data for it. So 0 represents air, and I've got this tiles image, so 1 represents grass, and 2 represents dirt, and 3, 4, 5, 6, etc. You can just see there's some tiles I drew just for some testing. Okay, and then this stage has a bunch of functions which let me check if a tile is solid at a position. Okay, and let me set a tile at a float position. These are vector float positions. And I can get the position of I can turn a position into an index by first dividing it by 16. Okay, and that's because one float value is 1 pixel, and you can see these tiles are 16 pixels big. You can see in the corner maybe. 16 by 16. Yeah, they're 16 big, so one float value is 1 pixel. So I divide it by how many pixels are in a tile, and then check if it's outside the map. If it's outside the map, nothing, it's not a valid tile. Otherwise, I give you an index. This is still subject to change. I might just do pos to get tile from pos or whatever, because that would be much easier actually. Yes, and I can do things. I can like see if it's solid, if it's just not 0, because 0 is air and everything else is solid, or I can see if it's I can set it to whatever I want, and that's all well and done. I've got a stage which just holds all the world information, and then I've got some particles. Okay, particles. Right now I've just got the brick breaking particles that you saw earlier. So there's an enum called particle kind. Right now there's just broken tile, and there's a corner So that just represents if it's the first, second, third or fourth. And this is hopefully going to be a massive atlas one day full of all sorts of particles. But right now it's just this. 11 by 11 broken brick tiles. And each particle, so I've got a structure called a particle, which holds its kind, as well as a position and a velocity. Some particles might not have a velocity, so I'm thinking, you know, maybe they won't, maybe this will be part of this. But basically every particle does have a velocity, and everyone has a position, don't they? Or maybe they don't. But anyway, in this particle thing I have a simple function called update, and if it's a broken tile, then it just moves it. You know, but maybe something else like a dust particle from when you skid, that won't be affected by gravity. That's not going to fall off the world, is it? So each particle is going to have different behaviour, and obviously there'll be some very general stuff. You know, and then each particle gets drawn. So I currently just get the source from the image. So if it's a broken tile, the source is going to be a rectangle that starts at 0. It's going to be 11 by 11 because of how I've done it. And then I just get the position of it, so I just do some simple math to say, okay, the corner ranges from 0 to 4, so it should be 0, 1, 2, 3, or 0 to 3, sorry. So I just get that, times it by 11. Now I draw that bad boy in there. Then I have this sort of particle manager struct, which just holds a vector of particles, and it can update all of them and draw all of them, but it also gives me some nice functions to make particles right now. So I'm thinking a broken tile, or a broken brick for now, just has a slightly random velocity. And I just add a new particle, so these are all the different corners, and then they're offset from the position of where they should be spawned by a certain amount, and they've got the velocity. So yeah, those are the particles. So yeah, you can see the particles if I do this. Spawns them in at the right position. It's very nice. I think I'm very proud of these particles. Very proud of the whole thing, but it's a bit janky, so maybe I shouldn't be that proud. Obviously this is just for testing. Then I've got a player. A player gets spawned at a position, and it holds a whole bunch of stuff, because the physics and the logic for the collision is kind of complex. So it holds a bunch of values for like things that change, like whether to flip the sprite, if you're jumping, if you're grounded, if you're skidding. The step animation is like for walking, so it ranges from 0 to 1, and it just increments depending on how fast you're going. And if you stop, it gets set to 1, I think. And then a walk, basically that's the direction you're walking. You can either walk left or right. I thought I might as well use an enum because that's nice. It's a lot easier than just like a random value, like that could be like a U8 or whatever. That's confusing. What does 0 and 1 mean? You know, the compiler optimizes all this for you. It's brilliant. So then running time, that's how long you've been running for. And that's, you ever play Super Mario World, there's like a T meter. Well that's basically for the run speed, so you can see I speed up and then I reach the maximum speed. And maybe it'd be better if I had a big empty level to show you this, because I've sort of been testing and slowly adding stuff to the level so I can break blocks and all that. Then just a ball if it's running, maybe that should be up there. And then the sprite, which is just for drawing, so which one of these images to use, 0, 1, 2, 3, 4, 5 or 6, which is jumping, falling, skidding, running and walking. And it just holds its position, its previous position, which is useful for the collision and response calculations, the current velocity, the target x velocity, which is how fast you want to be going in the x-axis. So if you're running, you want to be going a high speed, but you want to slowly build up towards that. You want to have some acceleration. You don't just want to immediately snap to the high speed. And then your gravity, and this gravity changes depending on whether you're jumping or not. You've got a constant walk speed. These are some, they're not constants. These are subject to change. I could put them in a big block of constants, but I'm thinking maybe, for example, in an underwater level, you'd want your gravity to change or whatever. So for now, they're in here, but you know they could be put elsewhere if need be, and I think they will be when I do some refactoring. Now just initialize the constants. And some nice default values. So then for running, you have a beginning speed and an ending speed, and then you have the timer. So that like when the timer reaches 0.4, so it starts at 110, and when it reaches 0.4, it starts going from 110 to 150, so it goes from 0.4 to 1.2. So after 1.2 seconds of running from standstill, you'll reach this end speed. And you have just some like you have different velocity, you do have different gravity, sorry, when you're jumping, when you're falling. So if you hold down the jump key, you jump higher, which is nice. Anyway, so here's the update logic. So if you're not grounded, you should be affected by gravity. And you should make sure that you never go too fast to this terminal velocity here. And then there's the jumping logic. So you can try and jump or whatever, and then make sure that your gravity decreases if you're holding the jumping key. I still need to make it so the faster you run, the more you go, but whatever. I'll do that soon. And then there's moving left and right. So if you press the left key or press the right key, it sets your walk direction to be left or right. And if you're moving, if you say that you're walking left, or you were walking right, but you're no longer holding the key, then it stops. But only if you're grounded. Right now, I still need to work on this because this is to do with jumping, and the walking isn't as good when you're jumping. Then I've got this stuff just to see if you're running. I think this needs some working on, which is why I've got this nice to do here. But basically, you're not running if you're not going fast enough, and you can only run if you're going fast enough and you're walking this way. See, these look very similar. This looks like I could just do an if-else, but they are fundamentally different because they both have the and here. So if I'm not going fast enough and I'm not walking, then I'm not running. However, if the running was true beforehand, but I am and I'm not going fast enough, but I'm still holding a direction, then I'm still running. And this is for the skidding functions, which is very nice, which is very handy. Actually, I think I sort of negate the whole point of doing that by this next part, which is the running timer. That stays still whenever you're grounded or you're skidding, which I might need to change. But otherwise, if you're running, it increases. If you're not running, it decreases. And then it just clamps it between the start and the end time to make sure the timer doesn't go too high. And this is the skidding logic. So if you're walking the opposite way to your velocity, then you should be skidding. Then if you've started skidding this stage, this frame, so if you're previously skidding, if you weren't previously skidding and now you are, it dampens your velocity depending on how fast you're going. So I originally made a little graph, and I used some math equations. So this is between 0 and 1, but I made it between 0.25 and 1 to make sure you can't set the velocity to 0 times itself, because that'd just be too slow. So I've got this little graph here, and I was originally doing it with equations. So that's just the beginning and ending speed. But then I found a really beautiful, really lovely function. It's called remap, which does that for me basically. Which, yeah, just to do with it's from Macroquad, of course. And then if you've started skidding, I want the running time to be at the beginning of running. So I don't want it so you can stop skidding and then immediately start running at full speed again, because that doesn't really make sense, does it? Then you have a target velocity, which just does the thing, what I was talking about before. You've got the beginning time and the ending time, and it just depending on how fast you're running, or how far into the running time you are, it maps it between the beginning speed and the ending speed, and it makes sure it's no less or no more than the running beginning and ending speed. But if you're not running, then you should just be walking. I think this might have to change to self.running, but I'm not too sure, so I'll leave that for now. Like I said, this needs some refactoring. So then you move the velocity towards the target. So basically this to-target function right now, basically, so you've got a target velocity and a actual velocity. You should move towards your target velocity faster if you're... You should move towards your target velocity faster if you're going faster. Someone's knocking on my door. Just a second. But yeah, so there's a function here called toTarget, which just increments it. Say if you're at 0 and your target is 20, and you're going up in steps of 7 or whatever. Then it goes 0, 7, 14, and it would go 21, but since your target is 20, it doesn't go over the target, so it just goes and claps out of the top. So that's very nice. It just gradually creeps the velocity toward the target velocity. And then I actually move the player, and now I have to do some collision stuff, and this stuff is kind of wonky. Well, I still need to figure it all out properly, but basically there are 5 points that make up the player, like in Super Mario World. And you can see I actually draw them here. You can see you've got good eyes. You can see the blue one for the head, 2 red ones for the side, and 2 yellow ones for the body. And the yellow ones stand out because it's on black. And then they do different things. So the head one is the only one that can break blocks, and the feet one does foot checks, and the left and right ones do do wall checks. And then I actually animate the sprite walking. This stuff needs reworking, but I just set the sprite. And then the draw function, I just draw the points, which this is just for testing. I know I defined them earlier. And I draw the actual player. So yeah, I've got this loop, and I just set the camera depending on where the player is. And I draw everything. Now I have a little FPS timer. So this is my little platformer making. I plan to improve it quite a bit. But for now, I think it's doing pretty good. Yeah, the collision definitely needs some work. And I need to add better particles, and I'm going to add crouching and grabbing objects, sort of like in Super Mario World. That's been a very big inspiration to this project. As you can see, I have the idea of grabbing objects at the top. They were like Super Mario Bros. 2, and maybe signs and slightly cracked tiles. I've got all these test things drawn. So yeah, I plan to add lots of stuff to this. But for now, it's just a nice little basic demo. I think I can easily turn this into a nice little game, which I think will be quite cute and wholesome. And yeah, thank you very much for listening to this.